Welcome back to Code Meets World, and today we're looking at LeetCode problem number 43, which is called multiply strings. So if we're given two non-negative integers represented as strings, we need to return the product of the two of them, also represented as a string. And we can't use any built-in libraries or just converting the inputs to integer directly. So as an example, if we're given the number 2 and the number 3 as strings, we need to return 2 times 3, which is 6, as a string. Same thing down here, if we do 123 multiplied by 456, we should return 56,088 as a string. And what we're not allowed to do is simply convert this string to an integer, convert this string to an integer, multiply them together, and then turn it back into a string. That would be way too easy, and so they say that we can't do that. At the top, I'm linking to a video I did recently where I was doing addition with arrays, where you had to go through digit by digit and do the actual addition from scratch. So check that video out if you want to see a similar problem to this one. So let's go to the whiteboard, and I have the second example pulled up, which was 123 times 456. Now I'm just going to solve this really quickly using what we learned in school when we learned how to do multiplication for the first time, because we're going to have to write code that can pretty much do that exact same thing. So what we do first is we multiply the 6 times each of the digits in the top number. And feel free to follow along if you haven't done this sort of thing in a long time. But 6 times 3 would be 18, so we would write the 8 and then carry the 1. Then we would do 6 times 2, which is 12, plus that 1 is 13, carry the 1. 6 times 1 is 6, plus that 1 is 7. And then we can get rid of those values that we carried. And now we're going to do the same thing, but with 5 in the top number. And you might remember we have to add a 0 before we move on to the next digit. So 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus the 1 is 11. 5 times 1 is 5, plus 1 is 6. And then we can remove those ones that we carried. And then finally, because we're going to do this a third time with 4 in all three of these numbers, we have to again add zeros, but this time we add 2. We add an extra 0 each time. And then we do 4 times 3, which is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. And then we add all of these together at the end. Go with 0 and 1. That's 6, 1, 5. So we get 56,088, which is the exact answer that they told us in the example on the NeetCode website. My plan is to write code that can do this process. And so we're going to need to keep track of a lot of different things here. And now that we've seen this done by hand, I think it's easier to think about what variables we need and what process we need to follow. So to start out with, I know that we're going to need a carry variable to store whenever we have to carry the 1 when we're doing the multiplication. So I know we'll need a variable for that. I know that we're also going to need a way to store the final answer. So like I just showed, we need to add together each of these numbers that we get at each successive step into the sum. So my plan is going to be to have a sum variable, and each time I calculate one of these intermediate values, I will add it to the sum, so at the end we get the correct answer down here. Another thing we're going to need is a way to keep track of the current number that we're forming. And what I mean by that is, my plan will be to compute these values one by one. So I'll first have to find the 8, then the 3, then the 7. I need to store all of those somewhere, which I'll do in the current variable. And then once I have the full value, I will go ahead and add that to the sum. And I think how I'm going to keep track of the current is with a queue data structure. I'm not sure if we've talked about those yet on the channel, but basically it's like an array, but you can add easily to both ends. And the reason I don't want to use an array here is because I'm going to be kind of working backwards. I'm going to add the 8 first, then the 3, then the 7. So I'm going to be adding to the left-hand side of whatever data structure I use, which isn't really good for arrays because they append to the right-hand side. So I'm going to use a queue, and I'll show you how to easily make a queue. It's actually built in to Python, which is really nice. Then there's one more thing I think that I need, which is I need a way to handle the fact that I have to add these zeros each time we move on to the next number that we're finding with our multiplication. And I'm going to make that a variable called factor. I'll start with it equal to 1, because at the beginning we just multiply whatever we get by 1. But then after we compute the next value, which is 615, we need to then add a 0 to the end of it. So we could multiply it by 10. Same with the next value. When we find that it's 492, we need to add 2 zeros to the end of that. So we can multiply by 100. So basically this factor variable, I'm going to use to keep track of what I need to multiply the value of whatever step I'm on. I'll multiply it by factor, and that will leave me with the value that I'll actually bring to sum. So that was a lot of info. Let's walk through the problem again for maybe a step using these variables that I just described so we can see how this is going to actually work. So I'll write it out again. And this time I'm not going to do any math over here. I'm only going to use the variables that I created to do everything. So we'll start out by doing 6 times 3, just like last time, and that equals 18. So we know that there's an 8 that we insert into the queue, and then we carry the 1. So next we would do 6 times 2, like this, and that equals 12. But we have to remember to add the 1 from the carry, so we actually get 13. Meaning we'll put a 3 here, and the carry stays as 1 because we're carrying 1 again. Now I do 6 times 1, which is 6, but then we need to add the 1 from the carry, so we get 7. And we'll just add that in to current, and that's all we have to do. So now we can clear the carry, we can clear current, and instead add that value to sum. And again, because the factor is currently 1, we don't need to do anything. We don't need to add any extra zeros. So we're finished with the first step. I guess I'll go ahead and do all 3 so we can see how it works the whole way through. So now we're going to start with the 5 and do 5 times 3, which is 15. So we'll add the 5 to the queue and put the 1 in the carry. Then we'll do 5 times 2, which is 10, plus the 1 from the carry, gives us 11. Again, we keep the 1 in the carry. Finally, we'll do 5 times 1, which is 5, plus the 1 gives us 6. And now this time, because I forgot to do this before I started this step, but we need to increase the factor to 10 for this iteration, which will allow us to multiply 615 by the factor. So we'll add an extra 0 there, and then we'll bring that up to the sum and add it. So this ends up being plus 6150. Now we can clear the carry, clear the queue, and what I should have done last time, increase the factor by multiplying it by 10. Now our final step. We are on the 4 now, so we do 4 times 3, which is 12. So we'll write down the 2, carry the 1. Then we'll do 4 times 2, which is 8, plus the carry gives us 9. And finally, 4 times 1 just gives us 4. And now, because the factor is 100, we need to multiply current by 100, which adds the 2 zeros. And now we can add that onto sum. And finally, we can clear everything. And because there are no more steps to process, our final answer is going to be the sum of those 3 numbers. And if we look, these 3 are the same as these 3, so we know that we are indeed going to get the final answer, which is the same for both of them. So I think this setup is what I'm going to go for, and we'll be able to iterate over each of these numbers just using a nested for loop. So now let's jump to the code to see how we're going to do this. Right, so the first thing that we need to do is actually import the queue functionality that I mentioned that we're going to use for the current, which I am showing on the whiteboard. So we can do that by saying from collections import dq is the name in Python, and dq is just the queue functionality, and then I'll show you how to append a value to the left to insert something into the queue when we need that. So the first thing I need to do is initialize my sum, which I can set to 0, as well as the factor, which I will set as 1. And these are 2 of the 4 variables that I'm going to need. The other 2 I need to reset each time the loop iterates, so I'll add those in just a moment. So the first thing I'm going to do is, just like we showed on the whiteboard, I'm going to loop over the second number, so the bottom one, starting at the 6, and then I'll work my way to the left. So we will start by looping over num2. So we can say for I, and we can say in range. And this is going to be looping backwards, starting from the end of num2 and going back to the beginning. I've talked about this in a previous video, but the way we can do that is start at the length of num2 minus 1, then we're going to go until we reach -1, and we will decrement each time. And going until we reach -1 sounds weird, but that's because it is exclusive of the end bound, so it'll stop at 0. So this is how we loop over num2 backwards. And then we have to do the same thing for the first number, num1. So we're going to loop over num2, and for each value, we have to loop over all of num1. So we can pretty much say the same thing. For j in range, this will be the length of num1 minus 1. And again, we'll just say -1 and -1. And this is also where I can add the other 2 variables. So we need current, and then we also need carry, right, which I wrote down on the whiteboard there. So carry we can start out as 0 because there won't be any carry at the start. Current I can just set as dq, and this is how you initialize an empty queue using the dq library that we imported. Great, so now that we have both of those, the first step every time, like I showed on the whiteboard, is just to take the first value and multiply them together, and we need to add any carry that might be there. So we multiply the 2 numbers and then add the carry, if there is any. So I'll say product equals, and this is the one time where we have to convert the values into integers because we just simply can't perform multiplication without having integers at some point. So this is perfectly allowed and completely following the rules of the problem. But we can say product equals int num2 at position I, and we can say times int num1 at position j, like that. So that's multiplying the two numbers together, and then we need to add whatever the carry is. Now the carry starts at 0, but as we go through the problem, I'm going to set the carry based upon what we figure out is the solution to this multiplication problem. So then we can say we need to append whatever we get here to current. Because remember, on the whiteboard, for example, say that this results in 8. We need to set 8 in our current. So basically we need to put an 8 here and a 1 up here. So how do we do that? So we can say current dot, and the syntax here is append left, which means we're going to place whatever value on the left-hand side of the queue and insert it. We need to append product, which is, in this case, 18 when we multiply 6 and 3. Modular division, which is that symbol, by 10. Because if we take any number and we do modular division 10, it always leaves us with the ones place. So this will just take 18 and give us 8, and we'll append that onto current. Then the other value, which is the carry, we can set that equal to, again, it needs to be the 1, and we can get that by saying product integer division 10. Because if we do 18 integer division 10, we'll be left with 1.8. We'll drop the decimals, so we're left with 1. Now there is one additional thing we have to consider here, which is in the case where, for instance, we get to 4, or we get to the end, and which is index 0. At that point, we don't want to append to current whatever the solution is modular division 10, because if there's a carry, we just need to add it. What I mean is, for instance, if this instead of being a 1 was a 9, and so on our last calculation, 4 times 9 is 36, we can't just write 6 and carry the 3 because there's nowhere else. We're not going to do any more calculations with the 3. We need to write the 3 with the 6. So the queue needs to get both 3 and 6. So we don't want to actually do the modular division by 10 in that case. So basically, if j equals 0, meaning we're at the very last case, we want to say, and again, I still want to do this in the other case, so I'll just copy and paste that. But if j is 0, we just want to append the full product. We don't want to cut off any values. We just need the whole thing. But in the case where we're not on 0, we only want the ones, and then we will add the carry. So that looks good. And then once we come out of this, we need to do, I guess, something sort of tricky, which is we now have current, which is a queue of all the values. So for instance, say we have 36 in there, like in the case on the whiteboard. We need to take those values and we need to add them onto the sum. The way we can do that is a little bit tedious in Python. So we need to convert an array, basically, because a queue is just an array. We need to convert that into an integer and then add it to the sum. The way we do that is, if I'm not mistaken, there's a few different ways, but we can say sum plus equals, and then we can do this trick where we join. So basically, let me do this step by step. In Python, a map function takes some function. In this case, it would be str, which means convert something to a string. We want to do that to all the values in current. So this will take every value in current and convert it to a string. We want to join that set of strings with just the empty string. So we can say empty string dot join this. This looks funny, but this is how you convert a array of something and smush it all together. So we're taking every value in current and joining them all together. And then we need to, of course, convert all of that to an integer and add that to sum. Now I think we're missing one component, which, remember this factor thing. After we calculate current, we need to check, hey, what's the factor, and multiply that by current. So I can just do that here. So what this is saying is, after we perform all the calculations for a given subset of the problem, we're left with current, which is a queue of all of the values. We're going to combine that together into a string, convert it to an int, because this is how we convert an array of integers into just a single integer. And then we'll multiply that by factor, and all of that will get added to the sum variable, which we're going to keep track of over time. Finally, we cannot forget to make sure that we multiply factor by 10. So factor times equals 10. At the very end, we can return, we just want to return sum, but remember the problem wants it as a string, and we have it as an integer, so we need to change this to a string. So let's give that a run, see if we've solved the test cases, which will pop up down here. And we have. That passes for both of them. So let's go ahead and submit. Yeah, and that's working. It's good for memory. It's not amazing for runtime, and I'm not quite sure why. There's probably a nicer way to solve this, but to me this one made a lot of sense. This is what came to mind first, and I hope this has been insightful. So let me know in the comments if you have any other questions, or if you know a better way to figure this out. I'd be interested to take a look at it. See you in the next video.